I've taught many students that feel like they understand how to find a fraction of a number, but often they're just relying on a particular method that they've learned. You may have heard things like turn both numbers into fractions and then multiply them, or divide by the bottom times by the top. Now, these methods can be useful for some questions, but relying on just one technique means you don't really have all the skills you need to solve the most challenging problems. In this video, we're going to build up your understanding from the foundations up and use pictures and diagrams so that you understand this concept in a more complete way. The first question we're going to look at is a half of 12. Now, when you have a fraction of a whole number, it essentially means the same thing as a fraction times a whole number. So it's a half lots of 12, a half of 12. So we can replace that of with a multiply sign. Now the first thing I'm going to do is get my 12 counters. And then with my bar, because we're looking at halves, we're going to split our bar into two parts, two equal parts. And that's because we want to find half of 12. As you can see in a minute, it will be a little bit different if we find a third. And then all we're going to do is share our counters between the two halves, share them equally. And you can see that 1/2 is equal to 6. And the shortcut for this is, what we really did is we did 12 and we divided it by 2 to find that half. Now we're going to move this on to looking at a third of 12. Now, again, exactly in the same way as before, we can change that of to a multiply sign. And I'm going to start off with my 12 counters. But instead of the half, this time we've got a third. So our bar is going to be split into 3 equal parts because we're looking at thirds. Again, we want to share our counters equally between the parts. And then we want 1/3. And you can see that 1/3 is equal to 4 counters. What about an eighth of 40, or an eighth times 40? Well, let's get our 40 counters and we can get our bar. And this time, because we're working with eighths, we want a bar divided up into 8 equal pieces. So how do I find what 1/8 is? Well, I'm going to take my 40 counters, share them equally. You can see that 40 divided by 8 is 5. So 1/8 of 40 is 5. Now that all sounds good, but what happens if we change the numerator? We've been doing lots of ones where it's been 1/3, 1/2, 1/8. What about 3/8? Well, the same thing applies. We've found out that 1/8 is 5. So now we have to just find out what 3 of them are. So if we do 5 times 3, we can see that 3/8 of 40 is 15. And what we essentially did there is we had the 40, we divided it by 8 to find 1/8, then we times it by 3 to find the 3/8. Moving it on another step, how about 5/6 of 24? So our bar this time is going to have 6 equal parts. And in order to find the 1/6, we're going to do 24 divided by 6. And that's going to give us 4. So each of those sixths is worth 4. And we want 5 of them. So 4 times 5 gives us 20. Now, let's try this one. A third of 17. Now, you can see that this one is a little bit more tricky because if we have our 17 counters, they don't equally go into thirds. They don't divide by 3. They have a remainder 2. So how can we look at this problem in a slightly different way that means we can still solve it? Now, the way I would prefer to look at it is I would actually do this. So instead of having a third lots of 17, I'm just going to have 17 lots of a third. So if I have a third, I just have 17 of them. So here are my 17 thirds. Now, all we have to do with this is try and simplify this so we can get a whole number and a fraction, so we get a mixed number. So the 17 thirds go together to make 5, and we've still got 2/3 left over. So the answer is 5 2/3. And you can see on the top calculation there, you first go to 17 thirds, and then you can see that then simplifies to 5 2/3. So by switching the numbers round, we can actually look at the question in a slightly different way and solve ones where it's not easy to divide the denominator into the whole number. How about if it was 2/3 though? So we had 17 lots of 1/3. What about 17 lots of 2/3? So we now have a numerator that's above 1. Well, here's my 2/3. And what I would do is the image that I want to associate with this is I want 17 lots of those 2/3. So how many thirds is that? Well, 17 times 2 is 34. So we've got 34 thirds. But now we want to simplify that. So what is 34 thirds? Well, 33 goes into 3 11 times. So if we have 33 thirds, that's going to be 11. And then we're going to have 1/3 left over to make the 34th third. So we can use exactly the same idea with a numerator that's more than 1. Before we move on to the harder questions that we're going to look at in this video, I wanted to just have a quick look at the alternative method of turning the whole number into a sort of fraction by doing 40 over 1 in this example. So the way we solved this one was we did 40 divided by the 8 to get 1/8, which is 5. Then we times that by 3 to get our answer. If we use this method, we have to rewrite the question like this, and then we get 120 over 8, because we do 3 times 40 is 120, and 8 times 1 is 8. And we're stuck now with simplifying this to get to our final answer of 15, which is much, much more challenging, I feel, than the method that we've done before, and liable to make any mathematician cry, even baby Pythagoras here. Even with questions like this, where the denominator the 3 doesn't go into the 17, it's still quicker to use a slightly different way. Instead of writing the 17 over 1, we just know that we've got 17 lots of 2/3. So 17 times 2, we have 34 thirds. And so we can go straight to that, and then we can simplify from there. So for what it's worth, my opinion on the over 1 sort of method, I'm not really sure when it's more useful than the methods that we've just had a look at here. But what we're going to have a look at now are questions that kind of go further than that, and they have sort of missing numbers in different parts of the equation, which hopefully will give you something else to have a go at. Okay, let's move it on a step further and have a look at this problem. 3/4 of something equals 12. Now, this is where if we're going to use the kind of, two fractions multiply method, we kind of get a little bit stuck because we have, a box times 3, which we can't really do unless maybe we're using algebra, but this is a little bit before that. So let's see how we can use the bars and the work we've done before to try and solve this particular problem. Okay, what do we know? We know that we've got quarters. So we've got our bar, we've got our 4 parts, and we know that, well, what we don't know is that the whole bar, 3/4 of some number is 12, but we do know that 3/4 of it is equal to 12. That's what that statement's saying above. So if 3/4 of the bar is equal to 12, each of these quarters must be worth 4. 12 divided by 3 is 4. And that means the last quarter must also be worth 4, and therefore the whole bar is worth 16. Right, now we've changed it again. So now we've got a missing numerator. We've got some number of fifths amount of 20 times 20 is equal to 12. So again, with the bar, we know that we're working in fifths because we've been given the denominator. And we know that the whole bar is worth 20. Some number of fifths times 20. So we know the whole bar is 20. And we know that a portion of it, some number of fifths, is going to equal 12. Well, what's 1/5? Well, 20 divided by 5 is 4. So 2/5 would be 8. 3/5 would be 12. So 3/5 times 20 equals 12. Moving up another gear, we've got 4 over something times 30 equals 24. Now here, it's a little bit trickier because we don't know how big the parts are. Are they fifths? Are they sixths? Are they sevenths? We don't know. But what we do know is that 4 of them are equal to 24. And the whole bar, however many pieces that contains, is going to equal 30. So if 4 of these parts is 24, what's each part worth? It must be 6. 24 divided by 4 is 6. And then if the whole bar is 30, how many of those 6's do we need? How many of those 6's fit into 30? Well, 6 times 5 is 30, so they must be fifths. So 4/5 of 30 equals 24. And just to recap what we did there, we had our 24, we divided it by 4 to find out that each part is worth 6, and then we saw that if how many 6's fit into 30, so 30 divided by 6 is equal to 5. So they must be fifths. And now we come to our final problem. Something over 12 times 5 equals 4 and some number of twelfths. And this one, I believe, was actually invented by Peruvian goat herders in the late 18th century. And it's quite a challenging one. So for this reason, I'm going to give you a bit of a warning here. If you're not comfortable with all of the other stuff we've done in the video, I'd recommend practicing this before having a look at this question. Or you can just sit back and see what I think about it now. But what's nice about this is that we can actually apply what we've learned before to this problem, even though it's a little bit more open-ended and more challenging. So let's have a look. Firstly, the thing that I noticed is I want to kind of switch it around. So instead of having some number of twelfths of 5, I'd kind of rather think about it as 5 lots of some amount of twelfths. And that's going to make it a little bit easier to figure out what that number of twelfths is to start with. I know I've got 4 and something on the other side. So maybe what I can do is just start with how many twelfths are there in 4? Well, we've got 48 twelfths in 4. And then if I divide that by 5, because I want 5 groups that are going to equal just over 4. So if I wanted to make them equal 4, I'd do 48 twelfths divided by 5. And I'm going to get 5 groups of 9 twelfths. So 9 twelfths times 5. 9 times 5 is 45. But I've got these 3 extra ones here. So it doesn't quite work. Well, one way I could fix that is instead of having 5 groups of 9 twelfths, is let's fill the other 2 in and have 5 groups of 10 twelfths, and that way I'll be over into the 4 and all my groups will be equal, which is obviously what we need because we're doing 5 lots of some number. So we've got 5 lots of 10 twelfths. What does that make exactly? Well, 5 times 10 twelfths, that's going to be 50 twelfths, and if we simplify that, we're going to get 4 and 2 twelfths. So that works really well. So this one solution would be 10 twelfths and 2 twelfths. But we don't really have to stop there because maybe there's more than one solution here. And I'm kind of thinking that because we've only got 4 and 2 twelfths, maybe there's a slightly higher solution. So why not try 11 twelfths? So let's have a look at that. 5 times 11 twelfths. Well, 5 lots of 11 twelfths, we're going to have 55 twelfths. And that's 48 twelfths, which we know equals 4, and we've got 7 more twelfths. So that simplifies to 4 and 7 twelfths. That works as well. So that's our second solution. And then we might go on again. Well, why not do 5 times 12 twelfths? Well, 12 twelfths is the same as 1, but we can just go through it with the fractions anyway. 5 times 12 is 60, so 60 twelfths, which is the same as 5. So that doesn't work. So that's the kind of upper limit. We can't go to that. But we've found 2 solutions to that problem, 10 and 2 and 11 and 7. So that's fractions of a number. If you want to develop your understanding further, then check out our comparing fractions video where we look at 2 fractions and we try and work out which one's bigger and which one's smaller using different techniques and also using the bars as well.